Hello, this is Jim with We Develop Electrical Products. And this is our next project with the Arduino Uno. And with this project, we're going to make 8 LEDs and 1 RGB LED dance to music. We'll make it dance to the volume of the music, basically. As the volume changes, different LEDs will flash on and off. In order to do this is the hookup that we've got. You can see that we've got 8 LEDs here, 1 through 8, and we've got 1 RGB, a common cathode RGB, and they're connected to current limiting resistors, and the value of the current limiting resistors are all 220 ohms for all the LEDs. Like always, the LEDs themselves have a polarity to them. The long lead of your LED is connected to the high voltage, the 5 volts coming in. The low voltage, which is tied to ground, is the short lead. So that's the polarity that you have to have on your LEDs. Now I've got these LEDs set up such that I've got a red, green, yellow, and blue LED, and red, green, yellow, and blue. And then I've got the RGB, and that's connected up. You can see the common cathode of the LED. If we go to do a search, common cathode RGB LED, and you just click on one of these. This is the common cathode right here. These are common anodes up here. Common cathode would be similar to this right here. This is a common cathode. And we've got R off to the left here. That's pin 1. And then we've got our negative pin. And then we've got the green and the blue. So that's the common cathode. This is a common anode here. So we're using a common cathode, and you'll find that in your packet of stuff that you bought for these projects. And we have these connected up. LED 1 is going back to digital pin 8. LED 2 is going back to digital pin 7. LED 3 is going to digital pin 6. And LED, and so on and so forth, all the way down to digital pin 1. Now I had to make a change on this, and I'll just draw that out real quick. We had to change this pin here. We don't have it going to digital pin 1 anymore. We have it going over to digital pin 11. So we'll draw that real quick. Or digital pin 12 is where that's going now. So this is how it's all hooked up. And then we've got the RGB connector, or LED, and we've got that going back. The red is going back to digital pin 2. The green is going back to digital pin 10, and the blue is going to digital pin 11. So that's our hookup. And then we have the common cathode and all the commons for the LEDs going back to ground on the Arduino. And then we've got an input that we're going to be using, which is our music input. And we're going to be going to analog pin 0 with that. And we just got a couple wires going out from ground on the Arduino to analog 0. And we're going to wrap that around a 3.1 millimeter jack coming from your computer or your iPhone or Android phone, whatever, something that's going to pump music in. What I used is I had an analog jack coming from the headsets on my computer, and I ran a mixer from the computer so that I could play the music on an HDMI TV set and on the headsets. And I was pumping this music to the Arduino off the headsets from my computer. And then so I could hear the music, I was just pumping that to the HDMI of my TV set. And that's very easy to do. So that's the hookup that we've got. And like always, I'll have links in the description below to the schematic and the hookup for it. So you can link to that. And I'll have links to the script that we're going to be using, the sketch that we're going to be using. That'll be in the description as well, along with all the previous videos, links to those, and where you can buy this stuff. So those will all be in the description below. And now the script that we have, it's a little longer script than we've had in the past. We're using some statistics this time. We've got our LEDs, 8 LEDs assigned to pins, what pins they're going to. And then we've got our RGB, we're just calling the red LED, green LED, and blue LED from the RGB, and what pins they're going to. And then we've got some floats that we're identifying. And we've got an add, a mean, standard deviation, max and min. That's part of our statistics that we're going to be using. And then we got a microphone input, and that's going to A0. And then we've got a sound level, what we're reading from the sound level from that microphone input. And then we're declaring a function down here, or a library, statistics H. And where you get that library is off of GitHub. You can go to GitHub here, and I'll have a link to this GitHub. And in order to download this, all you have to do is go to the green here, the clone and download, and hit download zip, and it'll start downloading that. And you get the zip file all downloaded. And you come up here to your tools, or actually I think it's sketch, and include library, and add zip library. And you just add that zip, you just navigate to that zip file, and you add that. And that'll get you the statistics file that we're going to be using. The statistics .stats says how many data points are you going to take in order to do the statistics. And then we've got our void setup, where we're doing a lot of declaring of pin modes of all of our LEDs and making them all outputs. And we're doing digital writes to all of those LEDs to initially turn them all off. And then we're doing a stats reset, which stats reset, what that does in our statistics library is it resets all the data that's in the matrix of the library so that everything starts with 0 and you start fresh. And then what happens over and over again, we're going to create this variable that we created earlier, a sound level, and we're going to set that equal to an analog read of our microphone input, that A0 input. And we're going to put that in sound level. And then we're going to do a stats add data of that sound level. It's just going to continually add sound levels that we read from that analog input. And then it's going to do some calculations of the mean, standard deviation, the min and max of that stats library that's creating as it goes through this. And then we've got some if statements. The first one is going to be an if the sound level is less than or equal to the min value that comes out of this stats. Then it's going to turn LED 1 high, and it's going to make the control RGB which is a function that we created. It's going to send it 0, 0, and 255. If you go down here to that control RGB, it's taking an analog write of a 0, and a 0 for the red and the green, and a 255 for the blue. And then, so it'll be doing an analog write to all of those. So we've just got a bunch of if statements down here. And we've got another if statement. It says else. Once it goes through this, if it's not equal to the min, then it's going to come down here and it's going to set LED 1 low, and that control RGB is going to send them all zeros, so it's going to turn the RGB off. And then we've got another one where we make a decision whether it's a quarter of the mean, greater than or equal to a quarter of the mean, or if it's less than or equal to half the mean of the values that we're reading from that A0. And it's doing a digital write then again of LED 2, making it high, and then it's calling our function and turning on the red LED and turning off the green and the blue. And then it comes down here. If it's not that, it's going to make LED 2 low and going to turn our RGB off. So we've just got a series of 8 if functions, and varying values for our mean and our standard deviation, for our output from our radio or our computer that's playing the music. And our last if statement here is if the sound level is greater than or equal to the max value that comes from the digital, then it's going to make the digital write of LED 8 high, and it's going to turn the RGB, all LEDs on the RGB. And these are just things I just set up for debugging, which are serial prints of the sound level, the mean, the max, the standard deviation, and that type of thing. And then I've got a delay down here of 200 milliseconds so I can read those values. You can make this dance better if you get rid of that 200 millisecond delay, and I think I will get rid of that 200 millisecond delay, and do a save on this and do a compile. And it's compiling my sketch. And once it's compiled the sketch, it'll come back and say done compiling, and there's no errors. So this is our unit that we've got set up here. And so that's the way it is. And I'll show you what this looks like in real life. So here's the final product, dancing to our music. And I'll turn the volume up on the music here. So this is our project and how it turned out. So if you like this project, please hit the like button and subscribe to my videos so you're told about new videos as they come out. And enjoy the Arduino.